Okay, this is lesson 2. Um, okay, we're going to talk about negative exponents. So, what you need to remember is that there's a difference between a definition and a property. So, a definition is basically how mathematicians have decided we're going to handle something. For example, if I say 3 to the second power, there's nothing inherently about this notation that means that it's 9, except for that the definition of this exponent is that we're going to multiply the base times itself 2 times. So since mathematicians have agreed that whatever we put up here in the exponent means that that's what we've raised the base to the power of, then this expression means 9. Whereas a property is a fundamental characteristic of something. So 3 plus 2 equals 5, and 2 plus 3 equals 5. So the commutative property just explains how something it actually is. Okay, so keeping that in mind, when we talk about negative exponents are defined. Okay, they are a definition of how we're going to handle these. So, the definition of a negative exponent, for example, x raised to the negative n power, by definition, if n, this exponent, is any real number and x is any real number that is not 0, then x to the negative n will equal 1 over x to the positive n. So all this is saying is that when an exponential expression is in reciprocal form, so notice that this is the reciprocal of this, then the sign of the exponent, just the exponent, must be changed. Okay, I want you guys to take a minute and I want you to write this down in your notebook. I want you to write this definition down so that you can remember it. And just pause the video for a second. All right, now let's look at example 2.1. Okay, we have 1 over 3 raised to the negative second power. The way we will handle this is we're always going to go ahead and put it in its reciprocal form where the exponent is positive. So that means that this in reciprocal form would be 3 raised to the power of 2. So when we simplify this, this will be 9. Okay, let's look at B. 3 raised to the negative third power. We're going to put that in reciprocal form so that this exponent will be positive. So that will be 1 over 3 raised to the positive 3 power. So when we simplify that, that's going to be 1 over 27. Okay, now let's look at C. Now this is a little bit different because this time we have an expression where we have a negative in front of the expression. I want you to you could put your hand over that negative right here, or you could just kind of disregard it for a minute. If you look in the book, you see that they have like a picture of a finger just placed over that negative so that you don't get confused. You can do that, or you can just remember that when you put this in reciprocal form, it does not change the negative signs in front of the expression. Remember that this negative just means the opposite of, okay? So when you write it down, you could say to yourself, the opposite of whatever this thing is. Well, I'm going to take this and I'm going to write that in the reciprocal form which means it will change the exponent to positive. So the reciprocal of 3 raised to the negative power, the negative second power, is 1 over 3 to the positive 2. Now you notice that I bring my negative along with me. So this means the opposite of whatever this is. Okay, so 1 over 3 raised to the second power is 1/9. So the simplification of this is a negative 1/9. Okay, let's try another one. This time, you'll notice that this is in parentheses. Well, if it's in parentheses, we're going to first, we're going to keep it in parentheses. All right. So I'm going to just change this into reciprocal form. That negative 3 is going to stay in parentheses, but the 2 is going to remain positive. Now we remember what our rules are from algebra. If something is in parentheses, then that exponent applies to everything that's in the parentheses. So this means that this could be rewritten like this, right? Negative 3 times negative 3. So the answer to this simplification is 1 over a positive 9. Okay, and then finally, E, we have 3 raised to the negative third power. So we'll rewrite that as a positive exponent. So this is just going to be 1 over 27. Okay, let's move on to 2b. All right, so remember that definition of x squared is x times x, right? X cubed is x times x times x. And we know that if we were to say x squared times x cubed, that would be the same as saying x squared times x squared times x squared times x squared. I'm sorry, back up, sorry. X times x times x times x times x. All right, so if we counted all these, then how many times would be multiplying x by itself? We'd be multiplying x by itself 5 times. So this would be x to the 5th power. So you can see that if we add the exponents, that gives us our simplification. So when we multiply variables, we're just going to multiply the same base together, not just variables, but any base that's exactly the same. If we're multiplying it together with exponents, then all we have to do is add the exponents to get the final number raised to the power of whatever it is. So turn the page. If you look at example 2.2, let's try this. So we have x squared, y, x to the negative 5th, y to the negative 4th, x to the 5th, and x to the 0. Okay, and you'll see the definition right up there, product theorem for exponents. You should write that down in your notebook, product theorem for exponents. Oops, spelling it wrong. Here. E-O. It just says that if we have x to the m times x to the n, now you notice that these are different, right? That it's going to be x to the m plus n, which we just did. All right, now you'll notice that the bases are the same, so we're only adding together the exponents of bases that are alike. So, for example, this is an x, this is an x, this is an x, and this is an x. So we're only going to add these exponents together. Okay, so we have x to the negative 5th and x to the 5th, so that's x to the 0. So we're going to end up with just x square here, right? And then we have y to the first power and y to the negative fourth power. Remember that this has a 1. It's understood, right? So that's going to be y to the negative third power. So x squared, y to the negative third. Now, let's take this same principle and let's apply it when it's in fraction form. So remember from the previous part of this lesson that we can move these around, right? And that when I move this up here, then it's just going to be that same expression with the exponent with the opposite sign. So we're going to apply that to variables, okay? So we have y, negative 3, x to the fourth, y to the fifth, x to the negative 10th, y to the negative 6, x to the negative third, y to the 10th, and x square. All right, now we can combine all of our like terms in the numerator and the denominator, and then you can see where they have they write all their answers in the numerator. So you're going to be looking at each of these problems that they give you to see if they say write all exponents positive, or they could say all exponents negative, or they could say all in the numerator, which would be all in the top, right? Or they could say all in the denominator, which would be all in the bottom. So it really depends on the problem, how you're going to write your answer. Okay, so let's do this one. So we have x to the first power, and then we have x to the negative third power, and we have, y to the first power, y to the negative third power, and y to the fifth power. Okay, so that is y to the sixth, y to the negative third. So that's going to be y to the third. Okay, got all those. And then for the x's, we have x to the fourth and x to the negative 10th. Well, that's going to be x to the negative sixth. Okay, so those are what we have in the numerator. All right, in the denominator, we have y to the negative sixth and y to the 10th. Well, that's going to be y to the fourth. And then the x's are going to be x to the negative third and x to the second. So that's x to the negative first. Okay, so if we put all of those into the numerator, that means that I'm taking this expression and I'm taking this y up here. Well, in the numerator, that's going to be y to the third, y to the negative fourth, right? Because in the numerator, it's going to have the opposite sign. And the x's is going to be x to the negative 6 and x to the positive 1, right? So, yeah. So that means that the y's are going to be y to the negative 1, and the x's are going to be x to the negative 5. Okay. If it told you to do all exponents positive, then we would have had the same expression, except for it would have been in the numerator with positive exponents and a 1 on top. And this is the same as having everything in the numerator, and this is the same as having everything in the denominator. All right, let's look at the power theorem for exponents. This is 2C on page 28. So we can use the product theorem to expand expressions like x squared raised to the power of 3. Okay, so remember that x times x, this is multiplication, right? This is just we would say, oh, we count those, and that'd be x to the fourth. But here we're saying that we're taking everything that's inside of these parentheses and we're multiplying it times itself 3 times. So this is the same as saying x squared times x squared times x squared. Well, you can see that if we add all these together, that would be x to the 6th power. But the shortcut is just to multiply the exponent times the power that it's raised to. So this is x to the 6th power. All right, so if we take that and we apply it to example 2.4 on the bottom of page 28, we have x times x to the negative 3rd power raised to the power of 2. And then we have y times xy to the negative 2nd power raised to the negative 3rd power over y to the 2nd power raised to the power of 3, y to the negative 3rd power times x squared raised to the power of 3. Okay, so I'm going to basically just do this above where we are so that I can keep track of everything. Okay, so so this is x negative 3 raised to the power of 2. So this is going to be x to the negative 6th power. So I leave that x in front of it, right? So I don't lose any of that. And then this applies to everything in here. So this is going to be x to the negative 3rd times y to the positive 6th. Okay. And then we'll multiply that. So this is going to be x to the negative 5th times, and then y, xy, oops, write this yx, y, x to the negative 3rd, and y to the negative 7th. Oh, no, that's wrong. X to the negative 3rd, y to the negative 7th. Okay. And then we'll simplify this. This is x to the negative 8th and y to the 7th. Okay, so that's everything on top. Okay, now let's do the bottom. All right, this is going to be y. This one's easier. Y to the 6th. And then this, we'll simplify this first. This is x to the 6th. So this is y to the 6th, y to the negative 3rd, x to the 6th. And then we'll combine the y's. So y to the 3rd, x to the 6th. All right, and then in this example, they leave everything in the same, in the numerator and the denominator. That's they're going to leave everything positive. I mean, so I'm going to rewrite it over here so you can see that. Over y to the 3rd, x to the 6th. So I'm just going to rewrite this with everything positive. So that means I'm going to take this x and I'm going to bring it down to here. And I'm going to take the y and bring it down to up to here. So when I rewrite that, it would be y to the 7th, y to the negative 3rd, and x to the 8th, x to the 6th. Combined, that's y to the 4th over 8, 9, 10, 11, 12, 13, 14, x to the 14th. Okay. Now, I'm sure some of you guys can do this more in your head, but you should write down if you do it in your head, that's fine. But at each step, write it down. So say you can do this all in your head. Just write that x to the negative 5th power down at this point, even though you did it in your head, okay? Just so that you can show your work and we can see, so that if you make a mistake, you can see where you made it. All right. Last thing on this lesson is circle relationships. If you know the area of a circle, you can find the diameter of the circle and you can find the radius of the circle. And if we know the circumference of the circle, we can also find the diameter and the radius of the circle. So the formula for area is pi radius squared. And the formula for, so this is area, circumference is 2 times pi times diameter. I'm sorry, not 2. It's pi times diameter, circumference. It's pi times diameter, or 2 times pi times radius. Okay. All right. So if we have the area, so it's either this or this, and the reason why it could be either is because radius is twice the diameter. Okay. So example 2.5, which is on the top of page 29. First, we have the area of a circle is 12.2 meters squared. What is the approximate circumference of the circle? So first we have to find the radius. So we're going to take the formula for the area of a circle. Pi radius squared equals area. All right, but we're given that the area is 12.2 meters squared. All right, so then we have pi times radius squared equals 12.2 meters squared. All right, so if we take that, we can divide both sides by pi. And then that we're trying to get this radius by itself, right? Because we're solving for that, okay? So r squared equals 12.2 over pi, okay? I'm just kind of dropping this meter square over here because we're trying to find the number. Okay. Now we know that pi is 3.1. The abbreviation for pi is 3.14. We can put it into our calculator. There is a pi button on your calculator. So you could do 12.2 divided by pi, and it will give you, 12.2 divided by pi. And then, hold on just a second, guys.
Yes? What?
12.12 divided by 3.14. Okay, that I don't use the pi button. Just divide it by 3.14. I've got to figure out how to use the pi button. And I got radius squared equals 3.8853503018. It's obviously a long number. And then take the square root of that, and which is the square root button. It's under the tan button on the TI-30X. So R will equal 1.97 if we're rounding it to 2 places. So the radius, and you'll notice the squiggly line in your book, that just means approximately 1.97. Okay. So that's approximately what the radius is. Then we can find the approximate circumference by taking that radius and putting it into our formula. So 2 times 3.14 times 1.97. Okay. So 2 times 3.14, putting this in my calculator, times 1.97 gives me an approximate radius of 12 point. Well, what I got in my calculator is this, so I'll round it to 2 places. And remember that this is meters. All right. Okay, so let's do example 2.6. And take a minute, pause this and write this down if you do not have it written down so you can see all the steps. So, and here when I put pi, I use 3.14 for pi. Okay, so this is 2.6. The circumference of a circle is 8 pi centimeters. Now, in this case, they're not going to actually use the 3.14. They're going to leave pi written as the pi symbol. Okay, and then they want to know what the area is. Okay, well, if we know that the circumference equals 8 pi centimeters squared, and we know that the formula for, so that's 8 pi, and we know that the formula for circumference is 2 pi radius, we can divide by 2 pi, and you see how this cancels out, the pi cancels out, and then we can just divide 2 into 8, which is 4. So we know that our radius is 4. And if we want to find the area of that circle, then we just put it back into the area equation. So 3.14, we're not going to use 3.14. We're just going to use pi. So the radius is 4, so it's going to be just 16 pi centimeters square because the radius is 4, so 4 times 4 is 16. And that's the area. And then if we wanted to find a number without that, we would just multiply this times 3.14. Okay? All right, guys, go ahead and pause and try the practice problems, and then I will work them out for you, and you can check them. Okay, anything raised to the power of 0 is 1. So this is all 1. Oops. Oops, made a mistake. Hold on. All right, and I haven't checked these yet, guys, so I'm just working them out. Pi radius squared. So So 49. So that cancels. Squared, so square root of both sides. So the radius is 7. And then the circumference is 2 times pi radius. So 2 times pi times 7. So 14 pi centimeters. All right, let me look and check the problems real quick. So this is lesson 2. So negative 1/16, negative 1/16, x to the negative first, y to the fourth, and 14 pi centimeters. Okay, those are all correct. All right, I'm going to go ahead and stop this, and then I'll record your next lesson.